Good evening and welcome to tonight's video. Tonight's video we're going to be discussing one of the methods of calculating earthwork volumes. And basically what we're going to do is we're going to calculate volumes based simply on an area and an average depth. The math is simple for the most part. You just have to understand the concept of it. And that's what I'm here to show you. And before we waste any more time, I'm going to jump in and start with an example right now. Go up to the whiteboard and we'll start off really simple. Here we're going to have an area of land. And we're going to make us a square. Simple as that. Square, let's say it's going to be 25 feet on edge. Here's a square, 25 feet on edge, 25 feet. Each way, 25 feet. Now, there's our area. The next thing we need to do is know how deep an amount of dirt, or what depth of soil we're going to be moving as part of this construction process or as part of the design process. So now, to work our example, I'm going to give you some elevations. We're going to start off with the red pen, and I am going to give you the elevations of the land as it sits now. In other words, the natural ground. Matter of fact, I'm going to switch to green. Green to represent natural ground. So here we go. Let's say this elevation is 48 feet. I'm going to keep the numbers simple just to make the math easy. The concept is going to be the same. Doesn't matter if it's 48.175 or 48, the math and the concept are still the same. And we'll make this one 44 feet. This one 45. And this one 47. That is the elevation, height above sea level if you prefer, or height above whatever datum you happen to be using, for the existing ground. Now, I'm going to switch to black. Excuse me, dropped it. And we're going to give you the proposed elevation. In other words, this is what the elevation will be when construction is complete. And I'm going to write those numbers in a box. We're going to make this 46. This is going to be 46. This is 46. This is 46. And this is 46. Well, it's pretty obvious that this 25-foot square, when construction is complete, is going to be dead flat. Just like a pad for a building or a small structure, a garage perhaps. 25 by 25 is about right for a garage. So, we know what the elevation of the point is now. We know what the elevation is going to be. And now we got to come up with the difference in elevation. So the difference in elevation we start off at 44 and we're getting up to 46. The difference in elevation here is +2. Here we're starting off at 45 and we're going up to 46, so this is +1. Here we're starting off at 47 and we're going down to 46, so this is -1. And here we're starting off at 48 and we're going down to 46. This is -2. Well, this little example is a little more complex than I intended to for the first one, but you know what? You never learn to swim till the water's over your head, so away we go. What we're dealing with here is a situation where we are raising the ground on this side, because we've got two pluses, and we're lowering the ground on this side. That means that a certain area of this will be what's called fill. It's where you're filling dirt in, you're piling the dirt in there, soil, if you prefer. And here we're going to be removing the soil to bring the area down to the design elevation of 46 feet, because it looks like that's the number I chose. Once again, I'd like to remind you that all of these examples that I work up here on the board, they are all made up on the fly, so we're going to make mistakes sometimes, and that's how we learn. So step one here, before we even worry about the average depth, is to figure out where the cut area is and where the fill area is. So from here to here is all fill, and from here to here is all cut. But it's obvious that there's going to be a point at this line, along this line, where it transitions from cut to fill, or from fill to cut, depending on which way you're going. Our mission is to determine where upon that line that transition occurs. Well, on this end, we are a foot low, and on this end, we're a foot high. Well, doesn't take much intelligence to figure out that if you're a foot high here and a foot low here, that these two lines are going to cross right in the middle. Half and half. Half and half. What that means is that halfway down this line, there's going to be a point. It's going to be the grade point. We're going to call that the grade point. Now, grade is a term that we use to describe something that is at the proper elevation. And this is the grade point. That is the transition point between a cut section over here and a fill section over here. That one, we didn't even have to do the math. We could eyeball that. We didn't have to think about it very much. And look up here. We're 2 foot low. We're 2 foot high up here on top too. And the same thing is half and half. That means the grade point is right in the middle. So we now have, instead of having a 25-foot square, we have a 25 by 12.5 foot rectangle on each side. So each one of those is 25 by 12.5 feet. So now we've determined what our areas are and where our areas are. So the next step in the process is to determine the average depth. So the average depth for the fill side is going to be this. You got 4 points. You got one here, one here, one here, and one here. 4 points. What are the depths of those points? Well, we've got 0 plus 0, because there is no cut or fill, that's on grade. And here we have 1 and 2, plus 1 plus 2. And we average those out, divide that by 4, that's equal to 3 over 4, right? That is our average depth, or 0.75 feet. Average depth. Average fill equals 0.75 feet. Well, our area is going to equal 25 times 12.5, which is going to be what? 312.5 square feet, if I did the math right. So we've got an average fill, we've got an area, and now all we got to do is figure our volume, right? So our volume is going to equal 0.75 times 312.5, excuse me, And it's going to be a little bit hard to do the math in my head on that one. So, snap my fingers, put up my calculator, and we will figure it out. That is 234.375. 234.375 cubic feet. 234.375 cubic feet. Now, we don't deal with cubic feet when you deal with volumes of soil, but for now we're going to leave it like that. So we have a fill of 234.375. We're just going to round it to the nearest cubic foot. It's kind of silly to get into fractions of cubic feet when you're dealing with soil that you're going to be moving with a bulldozer. That makes no sense at all. So we're just going to say 234. Well, now we've got to do the cut side. And do the cut side, we're basically going to do the same mathematics we did the last time. It's going to be a little kind of superfluous because in this case, I believe, just looking at it, it's probably going to be identical. Once again, because we just make these things up on the fly. So we're going to make it up on the fly. We'll do our cut side and see how it goes. Again, our average depth. Our average depth is going to be -2, -1, 0, and 0 divided by 4. -2, -1, 0, 0. You almost don't even need to write the zeros in there. Divided by 4. In this case, we really don't even care about the algebraic sign. So we're going to have 3 over 4 again, which is 0.3 or 0.75. Excuse my penmanship there. 0.75 feet. That's our average depth for this area over here. That's this. This is all cut. But because this is a mirror image of the other one, we know our area is going to equal 312.5. And the reason we know it's 312.5 is that's half of the original, which would have been 625 feet, because it's 25 times 25. So our volume is going to equal 312.5 times 0.75, which is the same calculation we had before, which is going to give you equals 234 cubic feet, and that is our cut. So there's going to be a cut, put a C for cut, 234 cubic feet. 234 cubic feet of cut, 234 cubic feet of fill. If you ignore the shrinkage factors and the compaction issues, just on the face of it, you got it balanced. I didn't intend for it to work out that way. I thought it was going to be a little more complex than this. But that is the concept. Simple as that. The math gets a little more challenging than this, and you'll see that in the next example. But average depth times area equals volume. That's all you got to remember. Getting the average depth is always easy. You just add up every point, assuming there's straight lines between all points. You add up every point, you divide it by the number of points, that gives you the average depth. The area, well, you got to use some mathematics to figure the area. It can get pretty complex, but with something like this, we're almost always going to have a grid square in some form or fashion. So you're kind of limited to squares, rectangles, and triangles. Or variation thereof, some combination thereof, not variation. Anyway, that is one example of how this works. And I thank you for paying attention. And give me just a second to erase the board. And we're going to come up with another example. Thank you. Okay, here we go with our next example of how to figure the volume of earthwork based on average depth and area. Once again, pretty straightforward, but there's nothing like an example to explain how something happens or how something works. So we're going to do yet another example. This one will be a little bit simpler than the first because I'm going to make sure that this is all cut or all fill. Here we go again. We're going to draw us a square up here. This time we're going to use 20 feet instead of 25 compared to the last example. So the square is 20 feet on edge. And we have a existing ground elevation of 136, 141, 139, and 135. Okay, that is the existing ground elevation of the four corners of our square. And now, in our example here, we're going to do it a little bit different than last time. We are going to give you an example wherein we're going to remove a bunch of dirt. And your mission for this question is to find out just how much dirt was removed. So you went through with your surveying equipment, be it GPS or ground-based surveying, a level and a cloth tape. It doesn't matter what your methodology is. You establish that elevation on those points initially, and you go back after they come in and pan out a bunch of dirt, and you reshoot the same elevations because you want to figure out just how much soil, whether it was rock, topsoil, what have you, was removed from this particular site. So you come back and you take the same shots in the same areas. And here you get 131. Here we get 128. Here we get 124. Now let's make it 126. And 127 over here. We're using whole numbers. That's good enough. So, looking at this, the green is where you started out, the red is where you wound up. All of the red numbers are lower than the green numbers. That means that whole site got lowered. So the question we need to know is how much did it get lowered? Well, from 136 to 128, we went down 8 feet. From 126, or excuse me, from 135 to 126, we went down 9 feet. From 139 to 127, we went down 11 feet. This is going to be a lot of soil. And from 141 to 131, you went down 10. So those are our four numbers. That's how much lower the site is than it started out. Next stage, figure the average depth. Average depth. Okay, we've got 10 plus 8 plus 11 plus 9. all divided by 4. Add them up together. Get 18, 29. You get 38 divided by 4. And 38 divided by 4 is 7.5 plus 2, 9.5. 9.5. That's our average depth. Average depth, 9.5 feet. Now our area is 20 foot square, right? 20 by 20. So 20 times 20 equals 400. So we have an area, we have an average depth. Now we can do the volume. Simple as that. Volume is 9.5, 9 times 5, 9.5 times 400. Volume of 9.5 times 400 is 3,400? Yeah, that is right. 3,800. Because 10 times 400 would be 4,000, and half of 400 is 2. Take that away, 3,800. 3,800 cubic feet. But remember, we're dealing with dirt here. We don't ever use cubic feet, so we need to convert that to cubic yards. So 3,800 divided by 27 is what? Now for that, I do need a calculator. Get it out, fire it up. 3,800, excuse me. 27. That is 140.74 cubic yards of soil. You would never write 140.74. You'd probably just round it to 141. So this is a cut volume equals 141 yards. And that is a very straightforward and simple example of how this works. I'm going to give one more example in which we have to do a little more math to figure out where that grade line is, where that transition is from cut to fill. The first example we did that kind of split down the middle, so that denied us the opportunity to see the process by which it needed to be solved. So that's going to be the next thing we do. Give me just a minute to erase the board, and we'll get the next one going. Okay, here we are doing our third example of how to calculate volumes by area and average depth. This one's a little more complicated because we have an added step where we have to mathematically compute where the grade points are on a couple of these lines. But the first thing we need to do is figure out what our cuts and fills are. Now, I've drawn this problem up here in advance. I haven't worked it in advance. I just drew it up there so you guys didn't have to sit there and watch YouTube and wait for me to draw a picture. You've seen enough of that. But I drew it up here. We're going to do it on the fly, just like every other problem. It wouldn't be a real problem if I had it all worked out in advance. So what we're going to do is we're going to do our cuts right now, or fills, as the case may be. The blue numbers are the after, the green numbers are the before. Or if you prefer, in your example, the green numbers are the existing, and the blue numbers in the boxes are the proposed. So here, let's take a quick look. Here we started off at 777. We wound up at 774. That is a cut of 3 feet. Here we start off at 774. We go to 773. That is cut of 1 foot. Here we start off at 775 and we go to 772. That's also a cut of 3 feet. But here we start off at 770. We're one up at 774. That is a fill of 4 feet. All right. Now, it's obvious that we're going to have cut area and fill area. And it's also obvious that somewhere between this point and this point, you're going to make a transition between cut and fill. And here's how you figure that out. It's really simple in concept. It's actually pretty simple in execution. But it's one of those things, like a lot of things I try to teach you, is that rather than just look at the numbers and have a formula that you plug and chug, as we say, it's a whole lot better to actually understand what's going on rather than just plugging numbers into the formula, because you're understanding how to solve the problem, and if you're ever confronted with a similar but slightly different problem, you may be able to apply the lessons and the knowledge you have to a new situation that you can figure out when the time comes. So here's what we're going to do. The first thing we need to figure out is where is the grade point between this point and this point. Well, on this end we have a fill of 4, so the before and the after are 4 feet apart. And here we have a cut of 3, so the before and the after are 3 feet apart, but it's in an opposite direction. So we started off at 770 and wound up at 775. So this line is before, and this line here is after. That is the before and after construction situation on this little 50-foot square that we've got here. Now, for the purposes of this process, we assume a straight line between those 2 points. If it were not a straight line, we also assume that there would be more information. But in this case, we're assuming a straight line. The question is, where is this point right here on the line? Well, we know from one end to the other is 50 feet. That's our total. And we know our total change from 4 to 3 is 7, right? Total change. Equals 7 feet. Well, we know our total change is 7 feet. What we're trying to solve for is this distance from here to here. This distance right here. That's what we want to get. Question is, how do we get it? Well, real simple. All it is just a proportion. So the distance is 4/7 of the total, right? 4 divided by 7. It is a fraction of the total. 4 divided by 7 times 50, because 50 is the total distance, is going to give you this distance right here. So, through the magic of my calculator, that is, we're going to round to the nearest half a foot. We're going to say 28.5 feet. 28.5 feet from this end to our grade point. That's a little bit over halfway. Do 28.5. Well, if that's 28.5 and the total is 50, then this distance here has to be 50 minus 28.5, which looks like, what, 21.5? .5 feet. And that gives us our grade point right there. That is at grade right there. Okay, we've got that point here. On this line here, we're going to have another grade point. But we don't have to do the math again. You know why? Because we got 4 feet on this end and 3 feet on the other. From a fill of 4 to a cut of 3 here, and from a fill of 4 to a cut of 3 here, and the distance is 50 feet, just like it was in the other one. So this point to this grade line will also be 28.5. It's kind of hard to read, but it'll be 28.5, and this will be 21.5, for a total of 50. Which gives us this grade line right there. Okay, step 1 of the process is out of the way. We figured out where our grade line is. Now all we have to do is figure the average depth of this triangle and then whatever's left over. So the easy thing to do is do the triangle first. We could, start doing rectangles and triangles and solving for this big area, but it's a whole lot easier to just solve the triangle and subtract it from the total area. Don't make it hard on yourself. Be good to yourself sometimes. And this is one of those situations where you can be good to yourself. I'm going to reclaim the real estate here, and we're going to do some math. First thing we need to do is figure this area. We have us a right triangle, pretty straightforward. 28.5 on the side. And this is 28.5. The area is 1/2 the base times the height on a right triangle. And 28.5 times 28.5. Do the math. Take half of that. 28.5 times 28.5. You take half of that. You get 406.25. Correction, 406.125. But ain't nobody worried about 0.125 square feet in this situation. So we're just going to say 406 square feet. .406 square feet for the triangle. .406 square feet. Now we got to figure our average depth. Well, our average depth for these 3 points, you add them up and you subtract by the number of points. Well, we got 3 points. This is a 4. That's a 0, and that's a 0, because you have neither cut nor fill at either grade point. So our average depth is 4 plus 0 plus 0 divided by 3, which is the same thing as 4 over 3, which is the same thing as 1.33. We'll just say 1.33 feet. That is our average depth. Now, what is our area? 406 square feet, right? So our volume is going to equal 406 times 1.33 . Magic of the calculator again. Stick a little jump cut in there or something. 540. 540 cubic feet. And that is a fill, because this whole area here is fill. 540 cubic feet. Now, ultimately, we're going to deal with it in terms of yards or cubic yards, not cubic feet. But for right now, we're going to leave that just like it is. Okay, we got our fill triangle out of the way, but we still got a whole bunch of cut area, and we got to figure that. And that's what we're getting ready to do. Reclaim the real estate right here, and we'll figure our cut, and then we'll be at the end of this problem. I promise once you start doing this on paper, it won't take this long. It's just time consuming to explain as you go. And I thank you for your patience. Our cut area. Well, we don't have to do the math to figure the cut area. All we got to do is figure the total and take away the triangle. So our total area is 50 times 50, right? It's 2,500 square feet. That's our total area. Our cut area, in this case it is cut area, is going to equal 2,500 minus 406, because that was our other triangle in there, and that was the fill area. So our cut area is 2,500 minus 406, which is 2,094 square feet. (2,094 square feet). Now we got to figure our average depth, but this time we got 5 points, right? We've got 1, 2, 3, 4, 5, but 2 of those points are zeros. So our cut is going to start off here at 3 plus 1 plus 3 plus 0, which is that point, and then another 0, all over 5, because there are 5 points. So 3 plus 3 plus 1 is 7. That's 7 over 5. 7 over 5. Snap the calculator. That is an average depth of 1.4 feet. Average depth. (1.4 feet). Volume, and this will be cut. Our cut volume is going to equal our average depth of 1.4 times our area, which is 2094, right? 2,094. 1.4 feet times 2,094 square feet. Got feet times square feet, that's going to give you cubic feet. And it's going to give you about 2932 or 2931, depending on how you want to round it. 2,931 cubic feet of cut. I'm going to write it up here. Cut equals 2,931 cubic feet. And that is how you do that. Now we're going to play with it a little bit here and put some finishing touches on it. I'm going to reclaim this real estate. Very quickly. And show you the finished product. Now, normally this little square that we just did, the 50 by 50 square, would be one of a whole bunch that would be done over a whole project. But for the sake of simplicity tonight, we're only doing one square in addition to the ones we've already done. So, we have a cut volume of 2931 cubic feet. We have a fill volume of 540 cubic feet. So that gives us a net. Our net volume of dirt is a cut of 2931 minus 540, which gets you to 2391. If I did my math right, it's 2391. I hope I did, for all of our sakes. Doing math in the head sometimes gets to be a challenge, especially when you're talking to the camera and doing other things. But we have a net cut of 2391 cubic feet, which means we have a net cut in cubic yards. We got to divide that by 27 to come up with cubic yards. And that gives you about 108 or 109, depending on how you round, cubic yards. We'll call it 109. So that is our net cut for this little square. We have 109 cubic yards of extra dirt, which in the context of the project, you're going to have to figure out what to do with. It's going to have to go somewhere. It may be spread out somewhere else in the project, but for this little 50 by 50 foot square, we're cutting out a whole bunch of dirt. 109 yards of dirt is a whole lot of dirt that you need to figure out what to do with. Anyway, that is the example of volume based on average depth and area. Very simple process. The only complicated thing is figuring this transition point. If you get that transition point right, you'll get the rest of the problem right. Anyway, I hope you enjoyed this. I hope you learned a little bit, and I've enjoyed doing it. I hope you have a pleasant evening, and I look forward to seeing you again in my next video. Thank you, and good night.